Hello and welcome everyone. So my name is John Mark Libuon, and today I will be sharing my insights about how we can convert any continuous functions into a step functions. A continuous functions such as linear, quadratic, cubic, or any polynomial functions including the exponential functions. So before we start, let me give you first idea about real number. So I want to point out that all of the step functions that we want to convert will be based on the idea of the desired length of the steps of the functions. So also it would start into converting a real number into a certain interval at any given point on the real number. So for example, if we have the functions of x, like that one, is equals to a real number. So you see this green line, every time you are given a certain point on value of x, you will have equivalent of function value which is the same. Okay, and you can see this is a continuous functions. We try to use and utilize all the numbers we can see on the real numbers. Okay, so this time we have also a functions known to be an integer functions, and that is called the sometimes it's a floor functions, commonly used floor functions of x, like that one. And you can see we have a staircase function with the length of 1 unit. Okay, so if we try to think that this 1 unit represent a time, can be a 1 day, 2 days, 3 days. Okay, it can be represented by 1 month, 2 months. Okay, so it's an integer, but the continuous function it's just directly equal to the length of the given value of x. Okay, so this time we want to have some desired length of h. So one way to do this one will not be sticking right on 1 unit steps, but we'll try to have a certain length of step based on the real number value. But right here we have only 1 unit from the real number to 1 unit steps. So one way to do this one is to multiply by a certain length of that desired length of steps. Okay, so if after we try to multiply by integer, we will also try to make sure that we need to divide that one right here inside the integer functions in a way that we know that at any certain point on a real number we must have every length of h. We will also try to divide that h so that it both value from what you have multiplied right here will be cancelled out, and it will just the same point of the h, and that means that will be your or our desired length of h. And you can see that we have 1 unit. So now from these functions of real number green line, we can now utilize this length of h as our interval. You see that if I try to extend, and you see it will also try to increase. If I have 2.3, you can see that the endpoint right here is 2.3, and it will try to move into right, jump into the 2.3 on the other side. And the interval is 1, 0 to 2.3, and it will try to jump. And the next value it will try to move is on the 4.6 right here, and it will try to reach 4.6 above. Okay, so you can see. Okay, now we try to put this one into higher scale. to 10 units, and you can see that it will be 10 units length of steps. Okay, so that is how we try to convert this real number x into a floor functions of desired length. Thank you so much. I hope you have learned something, and we'll try to use this one to convert any continuous functions or polynomial functions into the step functions. Thank you so much. See you on the next video.